Hello, welcome to the Data Science and Domo webinar for November. We're going to wait for just a minute while everyone continues to join here. We will start in 1 minute. Thank you for joining on time. We'll be with you in just a little bit. All right, we are 1 minute in. Thank you for everyone that has joined on time. We're not going to wait any longer. We're going to go ahead and get started, even though it looks like there's still people joining. We will record the session, and we will send out the recording afterward for anyone that has registered, so you don't have to worry about that. My name is Andrew Chaffin. I'm a solution consultant and our data science specialist here at Domo. I've been at Domo 7 years. Prior to coming to Domo, I was working in lab management at a university, doing neuroscience research at Johns Hopkins. I've loved statistics and analytics ever since my first p-value. It was insignificant, I will admit. It was a little sad, but mostly I just remember the feeling of falling in love with statistics at that point. We also have Anthony Merrill here. He's an associate data scientist in Domo's data science consulting team. He's going to be our main presenter today. He has a master's in business intelligence and analytics from the University of Utah. He's a recent addition to our data science consulting team, but he's been doing advanced analytics and Domo automation here for quite a long time, several years. Prior to joining that team, he worked strictly with our largest and most complex data science pre-sales engagements. He has a collaborative and educational focus. He gets excited about teaching people about data science principles. So as far as format goes, we are in a webinar mode here. The presentation itself will be about 30 minutes, and there will be a 15-minute Q&A portion. We do want your questions, and you don't have to wait until the end to send those questions in. You can go ahead and send them during the presentation. If the answer is straightforward, I may just go ahead and answer you back through the Q&A interface. Otherwise, we'll answer it in the Q&A portion at the end. I'm not going to interrupt Anthony and throw him off of his game. If there aren't many questions, we may end early, but if there's a lot of questions, we may not get to all of them, as we are going to stop at 45 minutes. If you have questions we didn't answer, or if you're interested in learning more, you can go ahead and reach out to your favorite Domo contact, and you can set up a call with us. We'll also have my contact information at the end of the meeting, so you can reach out to me directly. So with that, Tony, the time is yours.
Thanks, Andrew. I'm excited to be here. So our purpose for these webinars is to help you understand how we do data science in Domo. Specifically for this webinar, we want to help you understand and answer the question of, am I ready for data science in my organization and in my role? So to give kind of a foundation, our focus is on the process of data science coupled with the right technology. A lot of people, have a misconception that data science is magical and mysterious. And although that is, sometimes feels that way, the reality is it is that combination of an effective process coupled with the right technology to provide those analytics that drive action in the business. So let's take a look at what a typical data science journey looks like. Now, a lot of times when people think about data science, they just think about this piece, the predictive modeling piece, where we dive into some machine learning algorithm or some deep learning algorithm to provide insights. And while that is a very crucial and effective part of data science, it's not the whole story. With Domo, we start from a foundation. We start with the business intelligence component, where we are trying to understand the business questions, and we're trying to understand the historical data that helps answer those questions. That then leads us to a data engineering piece where we are working with you to optimize the architecture of that data and to help you transform that data and clean it in such a way that gets you ready for the predictive modeling. At that point, we are then ready for the predictive modeling. And once we've found the algorithm that's a good fit for what the outcome is that we're looking to accomplish, we then take the next step, which is incredibly crucial that a lot of people miss. And it's putting that model into production and automating those insights so that you can continue to drive that action with new data filtering through. So a lot of that is built around monitoring the model accuracy, as well as developing those actions and interventions that are necessary. And then finally, once we've understood kind of the initial pass at the modeling and doing the predictive analytics, we aim towards an experimental design where we can get prescriptive analytics and help drive specific outcomes. Now, the focus for this webinar is to talk about the data science readiness offering. And as far as that goes with the data science journey, we are focusing on answering the question of, are you ready for data science? And the piece that we explore in quite a bit of depth, and I'll show you what that looks like in our demo, but we focus on these first two pieces of the data science journey. We explore in depth the business intelligence side, where we're understanding the business question and really dive into the data and understanding the historical data, as well as the data engineering piece of helping you architect the data in such a way that will set you up for success with the modeling, and focusing on that data transformation, specifically the cleaning of your data, so that you can be ready to go with the predictive component. Now, in the data science readiness offering, we set you up for that success, but we don't dive into the modeling quite yet. It just helps us answer the question of, are you ready, and what does that look like moving forward? So let's take a look at what that looks like in Domo.
So when talking about the data science readiness offering, we break that up into 5 main steps, and it's outlined here, where there are 3 different components to our engagement. There's a data science education piece, as well as an offering that our team delivers, and then there's an action item that your team needs to complete before we can move to the next step. So each one of these also builds on the previous step. So we'll talk about a conceptual model, we'll give you documentation around that, and then your action item is to complete that conceptual model. Once we have the conceptual model ready, we'll show you how to feed that into a metric map. And that will give us additional insight into what we need to do with the data and how we need to architect it. And then we get into understanding what the unit of analysis needs to be and what different aggregations need to happen so that we can combine that data into a single data set, a single validated data set that we can move forward on. At this point, we will run a data profile script, and I'll show you an example of what that looks like. But we'll also teach you about these main components that are crucial, understanding what to do with null values and missing data. How do we account for that? What should we do if our data is not normally distributed? How do we handle outliers? What about correlations? If there's 2 variables that are too strongly correlated, how do we account for that if we need to have those in the model? And what we'll do is we'll give you action items that then you'll complete a data set review where you will clean the data and get it ready to go. And then the final step is to, and kind of the culminating piece, is to help you create a value statement where we'll give you the value statement as well as data science recommendations to move forward. And that encompasses the entire kind of data science readiness. So let's explore this in greater depth. So let's look at step 1 here. So step 1, we're just focusing on the conceptual model. We have all the documentation here, and we'll go through this slide deck with you. But essentially, the conceptual model is meant to be a simple first step. We just want to identify a specific outcome, and then we want to brainstorm the different things that contribute to that outcome. And we outline those as predictors and controls, and we teach you kind of what those are. And this is a stage where you can create multiple conceptual models. If you have 3 or 4 initiatives that you're looking to do at your company, let's create 3 or 4 conceptual models. And ultimately, the goal of the conceptual model is to help us understand which outcome is going to produce the greatest return on the investment of our time, and which one should we focus on for the first engagement that's gonna yield a good return. Once we've chosen a conceptual model, then we jump into the metric map. What this looks like is then taking all of those columns that we use, and this example that we're talking about, it's employee churn. So we have all these metrics that we think will contribute to employee churn. And then we answer a couple of crucial questions. Where is it coming from? Is it in Domo yet? And if not, then can we get it in Domo? This piece is pretty crucial because a lot of times people will, at customers, as they're going through their data science initiative, they'll encounter situations where they don't yet have data in Domo. And instead of pausing for a bit and getting that data in Domo, they'll move forward with an engagement, and the data won't be complete. It won't tell the complete picture. And so we really want to focus on making sure that if you think it's important, then let's spend the time to get the data so that we can make sure it's included in the modeling. In addition to that, we add some variables that are some factors that are pretty important for us on our end. So understanding, the field name, what is the description of that, specifically because you are the business expert. We are the experts on the data science, but you understand your business. So sometimes there's column names that are names, the naming convention is a little bit different than what we're used to. So helping us understand what that looks like is crucial. And then understanding the unit of analysis for those different variables. And then also, is it something that needs to be calculated? Is it a calculated field that we need to account for? So once we have this metric map, then we have all the tools in place to know how we need to start combining this data together from all of these different sources and pulling the data in if it's not in Domo already. That helps us get this validated data set. So step 3 then is that validated data set, where we teach you a couple of things. We teach you about the unit of analysis, and that's specifically referring to the grain that we're looking at for a single row. So in essence, we answer the question, what does a row mean in the data set? Is it, are we doing a daily revenue forecast? Are we doing a monthly revenue forecast? Each one of those will define our unit of analysis differently. So for your use case, we want to make sure that we document what is the business question, in this case, which employees are likely to leave the company in the next month. Our unit of analysis for that is monthly observations of employees, which then informs our data architecture. One row needs to be an employee per month of employment. And that's how we need to architect the data through aggregations to get it that way. Now, once you have that ready to go, you upload a link to the data set in the data center so that we can do our magic. Now, before I jump into kind of the data profile and how we build that, this piece is important to understand, where we're trying to document everything that we're doing. Our goal with this data science readiness is so that you can be self-sufficient. We want to teach you how to fish, so to speak, so that your next engagement where you're looking to do data science again, you don't have to come to us and rely on us. You absolutely can, and we can assist you, but we want you to be self-sufficient so that you can take this and apply it to a new concept. In addition, we want to make sure that our documentation is thorough so that if 2 years down the road somebody asks you, or if you're not the person that's running it anymore, it's shifted to somebody else and they need to know what's going on, we want to make sure that somebody can easily look back and see exactly what we did and why we did it, and exactly what our line of thinking was, to make it easy to either replicate or modify if needed. So once we have that single data set and it's been validated, and and we've combined the data set appropriately so that we have all the columns that you think are important, we then run our data profile. And it looks a little something like this. We run a couple different data profiles. One is a histogram data profile. We want to look at the data, the numeric data, to see if we have this normal distribution. And what that means is that within plus or minus 1 standard deviation, we're encompassing about 68% of your data. If we go out to 2, plus or minus 2, that's about 95% of the data. And 3 standard deviations is then 99%, or mostly all of the data. Now, what this helps us do is it helps us quite a bit with the analysis, but a lot of times real-world data does not look so pretty. So in this case, we're looking at employee churn. That's our use case. So the data is HR data, and we look at the age of our employees. It's sort of normally distributed. I mean, it's better than what I've seen before, where some of these others, years in current role and percentage salary hike, they're not. They're skewed. It's a distribution that is not a normal one. In addition, this histogram data profile helps us understand the null values. Do we have any nulls in our data? In this case, we have gender that has about 5% of null values. We need to know what to do about this. That's our next step. Right now, we're just focusing on what does the data look like and what actions might we need to take to clean it up. So this is good to know. We'll note that, and we'll address it in the next step. In addition, we can run a Boxplot data profile, where specifically with a Boxplot, we're looking at the interquartile range of the data, everything that's from the first quartile to the third, and where the median lies for the data. In addition, we give the minimum and the maximum for that data set. Now, this is useful in helping us understand the deviations or the variation that occur between 2 categories. So in this case, our data set, we have an attrition column. The attrition is a categorical variable looking at a yes and no. Did they leave, did they not? And so in this case, when we're looking at age, broken out by these 2 categories, we see that there's a very clear difference between these 2 variables, or these 2 categories. Now, there are additional tests that we can run to see exactly how significant that variation is, but compare that to this card of percentage salary hike. That is quite honestly almost the same, right? So there is no variation between these 2 categories of attrition, except with, this range is a little bit wider. So that gives us a visual representation of maybe what we would need to do further tests. In addition, we can run a correlation matrix. Now, correlation matrix helps us understand the strength and direction of the relationships between 2 variables. So when we're looking at a 0 correlation, that means that it is a weak correlation, that there is no relationship or no strength between those 2 variables. If we go to a positive 1 or a negative 1, that indicates a strong relationship. And it will indicate, positive 1 is our positive correlation, meaning that if one variable is increasing, the other one is also increasing in a similar manner. Likewise, a negative correlation shows a relationship, but as one variable is increasing, the other one is decreasing. So let's look at a practical example. So in this case, we have a column called years with current manager. That is pretty strongly correlated at positive 0.77 with years at company. That makes sense, right? If for this company, it seems like people tend to stay with their current manager for for the time that they're at the company. So as the the years that they're with their current manager, that is strongly correlated with the years that they're at the company. This helps us understand how we need to address these highly correlated variables. Specifically, we want to make sure that with the model that we build, it is helping us understand the relationship between the independent variables and our outcome. With these two variables that are highly correlated, they're proxies for each other, so they're going to influence the outcome in unforeseen ways. So we need to make sure that we address that if we need to include both of these variables in the analysis. So that gives us good information, which, by the way, just to kind of understand the piece behind the scenes, for this correlation matrix, we use our ETL platform that allows us to drag in either a Python or R scripting tile where we can run code that's specific to Python or R to run a correlation matrix, or in this case, I'm doing correlation matrix and summary stats. So that's kind of architecturally what we see behind the scenes. So in addition to the correlation matrix, we can also run a scatterplot data profile. And this kind of explores that relationship, that correlation relationship between two variables, but it expands it in a way that is visually representative. So we can see that sometimes we have a 0.5 here, so it's a positive. We have a negative 0.5 here, so it's a negative correlation. But the shape of the data and what the data looks like is very different. Even with our 0.7 correlations, it's very different what the data looks like. And that's kind of how we want to look at this data set and your data set when we do this. It helps us understand, what does that relationship actually look like? Is it pretty random, like in monthly income? Or is it, ordinal, that there's clearly an ordinal component to the job level? And then we also see how strong is that relationship. And is it positive? Is it negative? That helps us understand, different things that we would need to do for the analysis. So all of this helps set us up to understand what we need to do for the next step, which is the data set review. So with the data set review, we've run the data profile, and we're going to spend time helping you understand what do we do with missing data. What are our options? What's the best approach for this, for the given task at hand? What do we do with distributions? What happens if we are not normally distributed? What about outliers? How do we handle those? And what do we do if we have, variables that are too strongly correlated for our analysis? How do we handle that? So all of that then gets put in a data set review where we list out the different variables that we need to take action on. So in this case, we had gender as one of them. The action that we want to take, the nulls were only 5%, so we're going to delete them. That's the best action for this. There might be other options, like we might want to impute and do some method of imputation. So for gender, we're going to delete them. Great. For distributions, there's a variable that we'll look at that is a count of job profiles. For this case, we need to do a mean centering because it's skewed left and it's also highly correlated with another variable. So we need to center that so that we can include it in our model. In addition, we have some outliers. We know employee salary, there's going to be some outliers, but those outliers actually describe upper management, so we need to keep them in. Age, however, we found that in our transformations, any nulls will automatically get put as 999. So we need to recode those. We need to actually find the birth date and get that in and correct it. And then in addition, we have a couple of variables that we're actually going to combine to create a new column, and that will help account for those highly correlated. So what that looks like in visual terms is we'll take these null values and we'll run it to where it will remove those nulls so that we can get back to 0. For our imputation of race and ethnicity, we have too many categories here, so we're actually going to collapse them and do some feature engineering to create an other category so that we can minimize the groups that we have for our race and ethnicity. Now, the count of job profiles is one that makes sense. We're going to have a lot more people that only have one job profile. And then as time goes on, there's going to be fewer and fewer that have more. Well, we need to include this in our model. So what we do is we take a mean and we do, here's the expected ratio. Here's where we're at. And then are we below that? Are we above that? And that helps us normalize that data. So once we have then cleaned the data and it's ready to go, we now have one final step in our data science readiness process. And that is looking at a value statement. This value statement helps us quantify the value of moving forward with this data science engagement. So what that looks like is a very simple process of answering a question, answering a series of questions that help us make a statement of we will do A for B, some audience, to improve C, some business problem, as measured by D, some specific business measures, which is worth E, some business outcome. And specifically, we want to understand, what is the strategic initiative or activity that we're trying to influence? Who is this for? What is the audience that we're looking to accommodate? What problem is this going to address for the business? And what specific key metrics will influence this outcome? And then specifically, this one that is probably the most important, but also sometimes the most difficult to quantify, is what monetary benefit will it generate? And this can be a ballpark if needs be. We like to be as specific as possible, but oftentimes we don't really know specifically, so we have to use our best estimate. So what that looks like in a practical sense is for this example that we've looked at with employee churn, we want to predict employee churn for the HR team and recruiting to improve employee retention and reduce our training costs as measured by our total active months, our employee rating, equity grants, bonus, and several other metrics, which is worth the opportunity. If we reduce employee churn by 5%, conservatively we're estimating that it will result in $1.3 million per year in savings. What this does is it helps us not only justify moving forward with a data science engagement, but also justify internally for you to get budget, to know that moving forward, it's actually going to help us if we move forward with a data science engagement. And so with that, with all of that in place, that helps us kind of quantify what a data science solution moving to the next step would look like. So to recap then, we are going from helping you brainstorm, building out a couple of different conceptual models, to choosing one, and then fleshing that out a little bit more in depth with a metric map, understanding where the data is coming from so that we can join it together and make sure that it's in the proper join criteria, and that we've got all the data, all the requisite data that we're using for the outcome. Once we have that, we educate you on the unit of analysis and different aggregations that need to be done so you can get it in a single validated data set. Once we have that data set, we can run a data profile so we can start understanding what we do about null values, distributions, outliers, correlations. And keep in mind, this phase, I've rarely seen clean data. In reality, when we're dealing with real problems, there's a lot more that we need to clean with each data set. So that's to be expected. This is a necessary and crucial step, but also a very expected step that we'll have to do to understand what to accomplish. So we'll give you some action items on how to clean that up. And then once we've cleaned up the data, we'll help you with the value statement. We'll give you data science recommendations to move forward, and we'll set you up for that next phase in your data science journey so that you can start to move down the path of predictive analytics and productionizing a model so that you can actually make business decisions based off of the analytics that we do.
So that gives you a brief overview of our data science readiness offering. With that, I will pass it back to you, Andrew, for Q&A.
All right, thanks so much, Anthony. We've had quite a few questions come in. We'll go ahead and get started with them. The first question was, we've had quite a few questions in Q&A about Jupyter Notebooks. The last one was, will the Jupyter Notebook be running on our systems, or will it be allocated in the cloud? You can obviously run Jupyter locally, but the Jupyter lab that'll be running in Domo will be running on cloud resources. So it won't be running locally, it'll be running in Domo's VPC in the cloud. The other question that we got, how long does this engagement take? Do you want to take that one, Anthony?
Yeah, absolutely. So it completely varies depending on what you're trying to accomplish. If you're looking to assess several different possible engagements that you want to go down, or possible outcomes that you want to predict, one for sales, one for finance, et cetera, then it's going to obviously take a little bit longer. One of the other things that takes a long time is we help you not only find where the data is coming from, to get all of the different variables that are going to be included in a model, but also we help you clean that data. And so depending on how long it takes to gather all the data and get it into Domo, and how long it takes to clean the data, it can be anywhere from, as quick as a month or up to, 3 to 4 months. But it kind of depends on the state of things internally. And that's kind of the whole point of this engagement, is kind of give us a jump start so that we know where we need to focus our time in the data collection and data architecture piece.
Great. The next question was, how much work should we expect to put in on our side? And then if you don't notice, I'm having Anthony answer some of the questions in audio, and I'm answering some of the questions in the Q&A, so we can get through all of them that we possibly can during this time. So you're going to have to listen and read. Apologies.
So the work that you need to put in on your side, this engagement is meant to satisfy a couple of things. One, we want to make sure that our side is helping to educate and up-level you in areas where you need it throughout this engagement. The whole purpose is that you can then take this methodology and basically rinse and repeat and do this over and over for other engagements, and you'll need less and less of our help to do it, right? We want you to be self-sufficient. So there should be a lot of work put in on your side throughout this. We'll help with the education piece. We'll help where needed if the skills aren't quite there to do some of this. But for the most part, it's going to be a lot of work on you. And really, we can't move forward with the next step until we complete the previous step, right? So keep that in mind, that whenever you do want to engage on this, you'll need to get a team together that can dedicate some time and some effort into making this happen, just so we don't drag it out for 6 months or longer.
Perfect. And then did you answer the specialized skills question? I know we documented that one here. Did you dive into that?
No, let's dive into it.
Okay. So the question was, what specialized skills do we need to have to do data science in Domo? And how should we prepare if we want to do this in the future?
So, fantastic question. We have a wide range of skill set with our customers. Some teams don't have anybody that can script in Python or R, and that's understandable. In those cases, you'll rely more on our team to help you with some of those scripting pieces. This engagement specifically, though, is built to just do the data aggregation, the data architecture, and the cleaning. So the only specialized skills that really are important on your side is any SQL skills or skills in the Magic ETL framework that we have in Domo. As long as you feel comfortable doing that, you should be good to go. I mean, this is meant to kind of help start at the foundation level, and it also is the whole purpose of this thing is to help you prepare for data science in the future so that you know what to put in place, what the data needs to look like. We set it all up so it's automatic in Domo, and then we're ready to go for a full data science engagement.
Perfect. We had another question. What is the difference between the plugins that we already have in our environment and the tiles? I'm not seeing the scripting tiles in my instance. Anthony, you want to take that one?
Sure, absolutely. So the plugins that we have, both the PyDomo library for Python and for the R plugin for R, they are useful and they're good. The challenge and limitations with those is that we're pulling data from Domo to a local environment, or if you stand up a compute environment in the cloud, then you can pull that data into a cloud environment outside of Domo. The challenge though is that you're running your script and then you have to push it back into Domo, and there really isn't a slick way to automate that process, right? So keep that in mind. The tiles were built with the idea to work seamlessly with the rest of the data, or with the rest of the Domo platform. So as the data is pulling in and Domo has updated that connection and automated that connection of the pulling of the data, then we can automate the running of these scripts, either to clean the data or run the modeling. So really the power comes from being able to not just run with the plugins, just running a data science script one time, and then every time you want to run new data, you got to pull new data in and whatnot, versus in Domo using the tiles, you can set it up to where you write it once, and then Domo notifies you if it needs attention, or through our model dashboard monitoring and whatnot. So there really is a power behind using the tiles in the platform, and that's why, frankly, why we built them. So if you don't have them in your instance right now, it's because they are part of our data science suite. So it is an additional offering, but we do include them and make them available throughout this engagement that we've been talking about today, the data science readiness. Perfect.
We had other questions around what's the pricing for this engagement. I think I'll go ahead and I'll take that one. The way that we do the data science readiness engagement, it's a fixed bid engagement, meaning that it's not tied to hours. We create a statement of work that we send over to you. It's a fixed bid, so no matter how long it takes or how many hours it takes, you have your fixed bid cost. It's about $20K. It's about $20,000. That can vary a little bit depending on the complexity of the use case that you're planning on, or on the number of use cases that you'd like to compare. We have some customers that want to take 4 or 5 different use cases and compare them and stack rank them as far as what they actually want to get started with. So it varies a little bit on the complexity, but you can plan around 20 grand for this engagement. And as part of that engagement, the data science suite, the tools that we showed you in Domo, like the Python and R scripting tiles, the data science widgets, the full data science suite, it's made available in your instance in kind of a trial mode, if you will. We don't charge you for that, but you're welcome to, we're going to use those tools in that engagement. And then if you want to move forward from there, then you can decide whether you want to purchase the data science suite and continue on yourself or use more consulting. So
one thing I'll add to that as well, keep in mind that throughout this engagement for the data science readiness, we also provide you with the data profile dashboard that we built, the histogram, Boxplot, scatterplot, correlation matrix. All of those are actually run and generated by Python scripts that we've built internally. And so we can, throughout that engagement, if there's interest, we'll share those with you so that you can do this again on, any other data set for any future, engagement that you want to do, either with our help or just if you're looking to do it internally.
Great. They had another question. Is there anything super proprietary here? Is there any of this that we couldn't do ourselves? And why would I do this in Domo rather than some other tool? Anthony, you want to take the first step at that, and I'll follow up?
Yep, absolutely. So one of the powers of using Domo, and part of the reason why we have built the data science suite into Domo to run seamlessly, is for the power that Domo gives in the automation of this data science. So like I mentioned in the beginning of this thing, a lot of times when people think of data science, they just think of the scripting aspect of it. But there's a lot more that goes into it. In fact, if you don't set your data up properly with the right unit of analysis or with the right date grain, you're setting yourselves up for either a model that won't run or a model that is very inefficient and lacks accuracy. If you don't clean your data, you're just begging for challenges in the data science engagement, or it won't even, run, depending on what the data looks like. So using Domo, we automate all of that. We pull the data in, we set it on a schedule. We figure out what we need to do to clean the data. Anything that we can't fix at the source, then we'll clean it, and we'll automate the cleaning of the data. And not only that, we'll also provide you with alerts around the data profiles that we showed if there's anything wrong in the data. So if down the road a bunch of null values get introduced in your modeling that we didn't account for, you'll be notified immediately via email, on your mobile app, so Domo can monitor these things for you. That frees up the analyst, that frees up the data scientist to be able to then focus on other endeavors. One of the most powerful components, though, is once we've done the modeling, so after you've done this engagement and you have the next step where you engage with the full data science solution and we do the modeling and we put that model into production, essentially what that means is that after we have trained the model, we've got the model, to deliver good accuracy with minimal error rates. We will then put that into production where new data will constantly be flowing in and will be scored by the model. And you can set that and essentially forget it and let Domo notify you if the model accuracy dips. There's a whole model dashboard that we talk about in other webinars, and we can discuss with you on this engagement as well. But there's a model dashboard that will monitor that model accuracy, monitor the error rates, the R-squared values, so that you can be notified if something is going on with your model, if it's dropping in accuracy. You can be notified immediately so that we can go in and see what's going on. But that's the power of having it in Domo. That's the power of putting it into production and making certain that those dashboards that you're using to run your business are constantly being updated in the appropriate way.
Another question that's gotten asked in kind of multiple ways: do we have to engage with your consulting in order to use the Domo Data Science Suite? How much does the Data Science Suite cost? Questions kind of around that idea. So I'll take that, and then you can add on, Anthony. So you do not have to engage with our consulting team in order to use the Data Science Suite. We feel like we've developed some great best practices, and we'd love to pass those on to you. We're working as hard as we can to document those, so you don't necessarily have to engage with us, but we expect to always be improving. We expect that, hopefully we can add some value in helping you get those first models set up in Domo. But no, the answer is no, you don't have to engage with our consulting team in order to get the Data Science Suite. He might pull me into that conversation, but that's your contact in order to get a quote on the Data Science Suite itself. So, anything you'd add?
No, I think I think you covered it.
The other question I got that I'd be interested in your opinion on, we have people asking, what recommendations we give as far as, how do I learn Python or R? How do I become competent? I mean, I don't know if you have specific resources that you'd recommend, or.
There's a lot of free resources online that walk through Python or R. One that I've used personally that I kind of enjoy, but it is a paid service, is DataCamp. But there are so many resources out there that you could use that are free, that give you a foundation. One of the things, though, that I found is that you can walk through little exercises to develop Python skills and R skills, and understanding the concepts, the foundation, is important. But the greatest education I've received was actually taking a problem and kind of stumbling my way through it when I was first learning this stuff. Needing to Google almost every time I wanted to do anything, Googling, how do I do this in Python? How do I do this in R? And it really is that's the quickest way that I've found to learn. And it just depends on, what what your learning style is and what you have available to you. But like I said, there's many free resources out there that would be beneficial.
Great. I think we are at time. I'm going to go ahead and try and respond to, I've got like a few more questions. I apologize if we didn't get to your question. Thank you for attending today. We will be following up with you. We'll be reaching out. I'll shoot you an email myself to follow up. We can answer the rest of your questions that you have and discuss your project specifically. So we look forward to working with you. And again, apologies if we didn't get to your question. Thanks so much for attending today.